Hello everyone, welcome to MindSpan Education. In last video, we saw continuity and we understood when a function is continuous and what are different type of discontinuities that a function might have, and how mathematically we can find whether a function is continuous at certain point or in an interval. So in this video, we are going to see the next topic which is very close to continuity, and its name is differentiability. Differentiability. So our today's topic is differentiability. It is very close to continuity only, and I would say these topics are uh, derived from limits only. So first you must understand what limits is and how limits are calculated in calculus. Then only you will be able to grasp these topics on continuity and differentiability. So if you have not watched those limits video, I would recommend you go to limits video in this playlist. This is already an ongoing playlist on calculus and optimization for GATE DA. So first you should go to other videos on limits and functions, then come back and watch this differentiability. Okay. In last video we saw when we say whether a function is continuous or not. Today we will take similar type of examples and we will discuss about differentiability of a function. This is just a fancy name of a fancy way to say that whether a function is has some differentiation or not at any certain point. So let's take an example. Let's talk about this curve. This is a function. It is going from A, let's say from A to B. We took the same example in the last video also. Now you notice that this function is first of all continuous from A to B. There is no breakage in the graph and there is no missing point, and we can draw this graph in one stroke. So this is continuous. There is no doubt about this continuous. But whether this is differentiable or not, how we can say that? Intuitively, how we can say by looking at a graph whether that graph is differentiable or not? We can say by looking on the graph as if the graph is a smooth or not. If there is any sharp turn in the graph, if there is a sharp turn, that means there might a chance that that function may not be differentiable at the point where the graph is turning very abruptly. For that matter, this graph, this function does not have any sharp turn. It is very smooth from starting to end, very smooth. So this is a differentiable function in this interval from A to B. This is differentiable because there is no sharp turn and we do not have any change of slope, abrupt change of slope in this graph. When I say slope, that means differentiation of that graph at any point. What I mean to say is, let's take a point C in between A and B. Then if derivative of this function at C means slope of tangent. If I draw a tangent at this point for this graph, then what will be slope of this tangent? Slope means tan theta. This is the theta for this graph. So tan theta is the slope of this graph, this tangent. When I say f dash x, f dash c, that means I'm just talking about the tan theta of this tangent. So whether this slope exists at any point or not, that's the only thing we check in differentiability of a graph. If slope exists, that means differentiation exists at point C, then we say that this graph is, or this function is differentiable at particular x equal to C. There is nothing else about this differentiability. So now how we calculate these things intuitively and how we verify if there is any formal mathematical formula or not. We will talk about that very soon. First, we understood the meaning of differentiability. That's very important. Meaning of differentiability is whether the graph is a smooth or not. So if it is a smooth, that means one more thing we can derive. One more thing what we can derive is, if a graph has any breakage point, let's say this graph is not continuous at all, then we cannot talk about a smoothness. Then there is a simply gap in the graph. If it is not continuous, then there is a breakage in the graph. Then it's very far to think about differentiability. So if a graph is not continuous, then we can say, if not continuous, then it will imply it won't be differentiable at that point, not differentiable. Okay. So this is a very, you can say, byproduct of continuity. If a graph is not continuous, then it won't be differentiable. And how we can intuitively understand this? That graph, if it is not continuous, then there will be some missing point or some breakage or jump discontinuity. Then it won't be a smooth at that point. So no smoothness means it won't be differentiable. But opposite is not true. If it is not differentiable, then there might be sharp turn in the graph. And even if there is a sharp turn, it may be continuous. There may not be any missing point. For the matter, if you take this shape, V shape, this graph here, right here at the tip, has very sharp turn and there is an abrupt change of slope. So it is not differentiable, but it is continuous. There is no missing point. So non differentiability does not mean discontinuity, but if it is differentiable, then it will be continuous, because continuity is first thing we check for differentiability. Okay. Now I will tell you another fact about this continuity and differentiability. What differentiability means is, when we say what we check in continuity for fx, we say function is continuous or not by checking continuity using 3 steps or whatever ways we saw in last video. Now differentiability, what differentiability talk about is, it just talks about differential of this fx, whether this differential is continuous or not. So differentiability is nothing but continuity of the differentiation of the original function. So if f dash x is continuous at x equal to c, then we can say f is differentiable at x equal to c. That means if it is continuous, it does not have any missing point or any irregularity at x equal to c. That means fx will be differentiable. Differentiation of fx will exist at x equal to c. That is an important point to keep in mind when we think about continuity and differentiability. Now let's take some example and try to understand differentiability in more detail. Okay, this was just an introduction what differentiability of a graph means. So let's take example. Let's talk about very famous function. Let's take fx equal to minus x when x is less than 0 and x when x is greater than equal to 0. This is just fx equal to mod x. This function is this only, defined in piecewise manner. And let's talk about this function. If we see the graph of this function, what we see here is, if we plot this function on the graph, we will get something like this. By intuition, I just said differentiability means this graph should be smooth in all the domain that we talk about. So for the domain, let's say real number, this graph has a sharp turn at x equal to 0. So it is not differentiable at x equal to 0. But how do we calculate? If we think about like this, whether f dash x is existing or not, whether f dash x is continuous or not, since we already know how to calculate continuity of a function, so let's just forget about differentiability for now, and we try to calculate continuity of f dash x. Let's see what happens. So first, continuity of fx is fine. Continuity of fx this is a must condition. So first we will check this. How do we calculate? Limit x tends to 0 minus left hand limit fx. This will go as limit x tends to 0 minus, and this portion will come less than 0. So minus x, and this will become 0. And again limit x tends to 0 plus, this is left hand limit, and this is right hand limit. First we are trying to calculate continuity of fx, and this will give you fx as x, which will give you again 0. Again function at x, equality sign is here, so this will also give you x, which is 0. So here by 3-step test we can see that all three values are equal. Left hand limit, right hand limit, as well as function value at x equal to 0, is 0. All are equal. So fx is continuous. Right? Now let's check the behavior of f dash x. We only check continuity. Even for fx and for also for the f dash x, we will check only the continuity. Since we are not familiar with derivability right now, so we will check the continuity only. So let's see what is f dash x. For this function, if we simply calculate f dash x, then we will get, for x is less than 0, we will get minus 1 for x is less than 0, and we will get plus 1 for x is greater than 0. For x equal to 0, we don't know what will be there. So that we have to figure out now. So let's draw this graph first. If we draw this graph, we'll get for x is greater than 0, plus 1 means here, and here open bubble. For less than 0, it's minus 1. So here. Now you can see this is f dash x. We have plotted f dash x, and we do not know what will be value of f dash x at x equal to 0. What? We do not know. You can see in the graph clearly that there is a jump at x equal to 0. There is a jump of f dash x from minus 1 to plus 1. So we can say that f dash x is not continuous at x equal to 0. By the graph and intuition, we can say that f dash x is not continuous at x equal to 0, right? By this graph you can see that. So we do not know what will be the value of f dash x at x equal to 0. So what we are trying to do here, since we proved this, that means I just said differentiability is nothing but continuity of first derivative. So if it is not continuous, means fx is not derivable, not differentiable at x equal to 0. This is also how you can prove and you can understand the meaning of differentiability. By just understanding the meaning of continuity and the differentiation, we can check whether function is differentiable or not, by just proving whether it is continuous and its derivative is continuous or not, right? This is intuitively how we think about differentiability of a function. But there is a separate formal definition also for the calculating differentiability, just like we have 3-step test for continuity. Let's check that formula now, formal definition. Let's talk about that. Formal, what is formal definition? How we mathematically prove differentiability of a function explicitly? We do it like this. We calculate left hand derivative like this, limit x tends to, let's say we are calculating at x equal to c. So c minus, we are approaching c from left side, and we do fx minus fc by x minus c. If you see in the graph what we are trying to calculate here, let's write RHD also, then I will explain. Limit x tends to c plus fx minus fc by x minus c. There are other ways to write this formula. We write in terms of h also, like sometime you will see limit h tends to 0 fc plus h minus fc by h. This is nothing but just writing in different ways. They both are equivalent. Here we have replaced x minus c by h. So h will go to 0, and we will calculate by putting h 0 plus and 0 minus sometime like this. So 0 minus here, by the way. This is just another way to write this function. So we will stick with one way to write this one, and we will use this. Okay. Now this is how we formally define differentiability of a function. Now let's see what this formula is trying to say. I just told you that differentiability is nothing but slope of the function. We talk about slope of that function and whether that slope is existing everywhere or not. Let's see what this function says. Let's take an example, this one only. This is fx and this is x, and this is fx equal to mod x. Mod x, we have a sharp turn here. Sharp turn should look like sharp turn. Okay, this is mod x, fx equal to mod x. Now, using this function, using this formal definition, let's see what it is trying to say. This is c, right? X equal to 0 here, c equal to 0 here. In this particular case, c is 0. When we reach 0 from left side, let's see what LHD tries to say, trying to convey us. What we are trying to do is, we are taking an x which is close to c, that is 0, and we are making this x as close as possible to 0. Now, what we are trying to calculate? This is fx and this is fc. So fx minus fc by x minus c. That means we are trying to calculate slope of this graph. So this slope will always remain same when we reach from left, when we try to go closer and closer to 0 from left side. This will always remain same, which is -1 in this case. Since this graph is fx equal to minus x in this region. So this will always remain -1, this slope, when we reach from left side. But what happens when we reach this from right side? Let's see what happens. When we reach from right side, if this is fx at x and this is 0, then what we are trying to calculate, fx minus fc by x minus c, this will give us slope of this line, and this line, this is 45 degree, and this line, slope of this line will give +1. Now you can see for the LHD we are getting -1. For RHD we are getting +1. They both are not equal. They should be equal. If derivative of a function exists, then both left hand derivative and right hand derivative should exist, and they should be equal. But in this particular case, it is not equal. So we can say that LHD not equal to RHD. That means sorry, differentiation of this function at x equal to 0 does not exist. We can say that differentiability does not hold for this function at x equal to 0. So it is not differentiable. Differentiable at x equal to 0. We can say this. Now, what I am trying to say here is you should understand the meaning of this formula. This formula, you should not just remember this formula. You should know what this formula trying to say us, right? So this formula is nothing but slope of the function when we approach C from left side, and this is slope of the function when we approach from right side. There should not be any mismatch when we go very close to C. If there is a mismatch, that means the curve was not smooth at that point. If it was a smooth, then there would not have been any drastic change in the slope, right? So this is how we check differentiability of a function. What we do, we first calculate left hand derivative, then we calculate right hand derivative using the limits what I just explained here, right? And if they are equal, then we say it is differentiable at that point. If they are not equal, we say it is not differentiable. Let's take some example. Let's see. Let's take another example. Fx equal to, let's say, minus x square when x is less than equal to 0, and it is 6 when x is greater than 0. Just a simple example. Now let's calculate this using our formal definition what we just defined. So what we will do, first we will calculate left hand derivative. What is the formula? Limit x tends to c minus remember that we are calculating at x equal to 0 here. So in this case c is 0 for us. We are writing formula for now. So fx minus fc by x minus c. So in this particular case c is 0, so x tends to 0 minus, and fx 0 minus means less than equal to 0. This part of the function will come minus x square minus fc means f0, same f0 will be 0, and x minus c. What we will get? Limit x tends to 0 minus, and we will get minus x. We will get 0 ultimately. Now if we calculate right hand derivative for this function, what we will get? Limit x tends to 0 plus fx minus fc by x minus c. So we are approaching 0 from right side. So which part of the function will come? This part, 6. So what we will get here? Limit x tends to 0 plus, and function will come 6, and minus fc. Fc means at 0. At 0 we will get this function equal to, equality sign we have here. So at 0 we will get this one. So 0 only. By x minus 0, x minus c means x minus 0. So we will get 6 by x, which we will get, let's just remove this. What we will get here? Limit x tends to 0 plus 6 by x, which is undefined. You can say undefined, which means anyhow, which means this right hand derivative, we did not get any proper number. So we can say that left hand derivative was not equal to right hand derivative. So this particular function, this whatever we defined here, this particular function fx was not differentiable at x equal to 0. We can say this. What we can say is this fx is not differentiable at x equal to 0. So this is how we find or check, this is how we verify whether a function is differentiable at x equal to particular point or not. And intuitively, this is how we understand. This is what I explained at the very beginning, what differentiability means and how we think about, how we imagine. If you can't imagine about a mathematical problem, you won't be able to understand properly. So this is how we imagine whether a function is differentiable or not. This is how we intuitively decide, and this is how we using this using this formula. This is how we formally define whether a function is differentiable or not at particular point. Now, these were simple examples, but to understand the topic, you have to practice a lot. Without practicing, you may think that you understood the topic, but in complicated problems, you will get stuck if you have not practiced well. So you have to practice a lot of problem on continuity and differentiability. And differentiability. Either you practice using some standard book, or we have already put a lot of practice problem which are very close to gate level. I would recommend you to not go very deep in this topic, because this is only shallow topic for gate DA point of view. So we have put a lot of problem right here. You can practice here. What you can do is just go to mindspaneducation.com. This is our website, and go here and go to the under the courses section. There is a calculation optimization course. If you go here, you will see a lot of practice problem already there. In the this is just demo version. Under the actual problem, there are a lot of practice problems that I have already included. Go there and you can solve them in gate like environment. It will be like this only. This is just for demo purpose. And here you can attempt those questions and you can check detailed solution once you submit the quiz. You can verify and you can check whether your answer were correct or not, where you need improvement and what mistakes you did. So you can come here and do the practice. So wherever you practice, it doesn't matter whether you practice here on our platform or you practice using book, it's fine. But I would recommend you to do the practice a lot on this topic, which is very important in calculus, in all the mathematics. Practice is very important. If you don't do the practice, you will not get the topic. You will make mistake in exam and you will end up losing marks. So do the practice, and we will meet in next video with some more exciting topics and more exciting examples. Thank you very much. Happy learning.